Hello, I'm Joseph Kasser, and welcome to this podcast where the AI team does a deep dive into some application of systems thinking.
Welcome back, everybody, for another deep dive. This time we're tackling a really fascinating topic: how to create a classroom that really prepares future systems engineers. We're calling this one Balancing the Classroom. Our main source is a research paper.
Cool.
It's called Introducing the Balanced Classroom, Applying Systems Thinking to Systems Engineering Education
Catchy.
by Joseph Kasser.
I like it.
And he's got tons of experience in both systems engineering and de-education. So buckle up.
Yeah, it's a really interesting area, because it's not just about, teaching those facts and formulas. It's about like fostering a mindset,
Yeah.
like a way of thinking that equips them to really handle those complexities of real-world systems.
So true. I'm already getting excited.
Yeah.
Okay, so right off the bat, Kasser throws down a challenge. Think about those part-time mature students. In postgraduate systems engineering programs,
Yeah.
they're juggling jobs, families, maybe even side hustles.
Right.
Time is their most precious resource.
Yeah.
But they also come in with these high GH expectations. They want practical knowledge that they can apply immediately to their work.
That's such a crucial point.
Yeah.
I mean, these aren't your, typical students straight out of undergrad.
Yeah.
They're bringing years of experience, maybe even some hard-won lessons to the table.
Yeah.
And they're not just looking to like fill a knowledge gap,
Yeah,
They want tools and strategies that'll make them way more effective in their careers.
exactly. So how do you design a classroom that caters to that? I mean, honestly, who hasn't sat through a lecture that just felt like it was sucking the life force out of you? Kasser actually starts by debunking some common myths about learning,
Oh, interesting.
things we've all probably seen in those infographics floating around the internet.
Oh, yeah.
Like the Dale cone and the learning pyramid. Have you heard of those?
Oh, absolutely.
Yeah.
The Dale cone.
Yeah.
Yeah.
Familiar with that?
I'm trying to remember what it looks like exactly.
It's like a cone, and it shows like
Oh, yeah.
Yeah.
Different ways of learning.
different ways of learning. Yeah.
Yeah.
And then the learning pyramid that shows like lectures at the bottom as least effective, and then teaching others at the top as the most effective.
Yeah, I mean, I have to admit, I was surprised to learn that those models, which have been widely accepted, for decades, they're essentially based on misinterpretations, and they lack solid empirical evidence.
Wait, seriously? So that iconic pyramid,
Yeah,
it's all bogus?
pretty much, yeah.
Wow. I'm learning things already.
Yeah, and Kasser digs into research dating back to like the 1950s
Wow.
and even more recent studies to make his case. So, if those widely accepted models aren't reliable, what does the research tell us about effective learning, especially for systems engineers?
That's where things get really interesting. Kasser champions something called authentic learning. What do you think he means by that?
Well, think about it this way. If you're trying to prepare someone to be a surgeon, you don't just have them read textbooks and watch videos. You get them into like a simulated operating room where they can practice, procedures on those lifelike models.
Uh-huh.
Yeah.
So it's about creating learning experiences that mirror the real-world environment as closely as possible.
Exactly. And for systems engineers, that means moving beyond those abstract textbook problems and giving them opportunities to grapple with those messy, complex challenges
Yeah.
that they'll face in their careers.
Okay. Kasser also dives into the importance of cognitive skills, specifically critical thinking. He even suggests using Bloom's taxonomy as a framework for assessing those skills. Have you ever used Bloom's taxonomy in your work?
Absolutely. It's a really helpful tool, for breaking down complex tasks into those different levels of cognitive skills, from basic knowledge recall to like higher level thinking, like analysis, evaluation and creation.
Right.
And in the balanced classroom, Kasser emphasizes those higher level skills.
Yeah.
Yeah.
Let's talk about the elephant in the room, attention span. We've all been there, right? Zoning out during a lecture that seems to drone on forever. How does the balanced classroom address this very real problem?
That's a key consideration. Research shows that attention naturally wanes over time, especially during passive activities like listening to a lecture. So the balanced classroom is specifically designed to be dynamic, to keep students actively engaged and prevent those mental snooze fests. It's a blend of lecture-centric and exercise-centric learning, carefully calibrated to maintain attention and maximize learning.
Yeah.
Interesting. And one of the ways it does that is through student teams. But Kasser doesn't just throw them together randomly. He outlines specific requirements for forming those teams, and some of them might surprise you.
Oh, I'm intrigued. What kind of requirements are we talking about? Is it like personality types or?
It's actually even more interesting than he suggests having at least one male and one female in each team, as well as a mix of ages and nationalities if possible.
Wow, that's really specific. I would have thought the focus would be solely on like academic backgrounds or skill sets. What's the rationale behind that kind of diversity?
He's essentially trying to create a microcosm of a real-world work environment.
Yeah.
I mean, in most industries, you're going to be collaborating with people from diverse backgrounds and perspectives, so why not build that into the learning experience from the start?
Makes a lot of sense. It's not just about learning the technical aspects of systems engineering. It's about developing those soft skills like communication and collaboration that are crucial for success in any field.
Exactly. And Kasser takes it a step further. He actually makes the team formation process itself a learning experience the students have to analyze the requirements, figure out how to meet them, and then present their solution to the class.
So it's like a mini project within the larger course structure. They're getting hands-on experience with those real-world dynamics right from the get-go.
Right. And sometimes he'll even throw in some intentional ambiguity in the requirements, forcing the students to clarify assumptions and really think through the problem.
That's brilliant. It's almost like he's setting little traps to help them develop those critical thinking skills and avoid making costly mistakes in the future.
It's all about learning by doing, which brings us back to that concept of the flipped classroom by moving the lectures outside of class time. Kasser frees up those precious in-class hours for more interactive activities.
Okay, so let's dig into that a bit more. How does this flipped classroom thing actually work in practice? I mean, we've all seen those online courses with endless hours of pre-recorded lectures. How do you keep students engaged and prevent them from just tuning out?
That's a valid concern, and Kasser addresses it head-on. Instead of just recording hour-long lectures, he breaks them down into smaller, more digestible chunks, typically around 10 to 20 minutes each.
Ah, so it's like the bite-sized learning approach that's so popular these days. Make it short, sweet, and to the point.
Exactly, and this chunking allows for more flexibility, too. If a particular topic needs to be updated or clarified, he can just re-record that specific chunk without having to redo the entire lecture. It's like a modular approach to teaching, just like systems engineers use for complex projects.
I like that analogy. It brings a whole new level of efficiency to the teaching process. But what happens during the actual class time? If they've already watched the lectures, what are they doing in the classroom?
That's where things get really interesting. Instead of just rehashing the material, Kasser uses those in-class sessions for what he calls interactive review. He'll guide the students through the key points of the lecture, pausing for questions, clarifications, and discussions.
So it's not just a passive listening experience. It's an opportunity for them to actively engage with the material, ask questions, and test their understanding.
Exactly. It's a much more effective way to ensure that everyone's on the same page and to address any lingering confusion, and then to really solidify the learning. He'll often incorporate group activities or mini exercises related to the lecture content.
So they're immediately applying what they've learned, which reinforces the concepts and helps them make those connections between theory and practice.
Now, another element of the balanced classroom that I find particularly intriguing is the use of what Kasser calls knowledge readings.
Oh yeah, we touched on that earlier. It's where student teams analyze and present summaries of key research papers or book chapters, right? Tell me more about how that works. It seems like a really effective way to get them engaging with the material on a deeper level.
It is. And Kasser provides a specific framework for those presentations, pushing them beyond simple summarization. They have to identify the main points, explain their significance, connect them to other concepts they've learned, and even draw their own conclusions or lessons learned.
Wow, so it's not just about regurgitating information. They're really having to think critically and synthesize those ideas in their own words. It's almost like they're becoming mini experts on that particular topic.
Exactly. And by presenting their analyses to the class, they're not only reinforcing their own understanding, but also contributing to the collective learning of the group. It creates a dynamic exchange of ideas and perspectives.
And I bet those presentations spark some lively discussions and debates. That's where the real learning happens, when you're challenged to defend your ideas and consider alternative viewpoints.
Absolutely. It's all about creating that intellectually stimulating environment where students feel comfortable asking questions, sharing their insights, and even respectfully disagreeing with each other.
This is all so fascinating. I'm really starting to see how these different elements, the teams, the flipped classroom, the knowledge readings, all work together to create a truly balanced learning experience. But we can't forget about the hands-on component, the actual exercises where they get to apply their knowledge and skills. What are some of the key characteristics of those exercises in the balanced classroom?
Well, as we touched about earlier, it's all about authenticity. They're designed to simulate real-world scenarios as closely as possible, pushing students to think critically, creatively, and collaboratively.
So we're not talking about those textbook problems with a neat little formula to plug in and get the right answer. These are more open-ended, complex problems that require them to really think like systems engineers.
Exactly. It's about moving beyond those simplistic plug-and-chug exercises and challenging students to grapple with the messy, unpredictable nature of real-world systems.
Okay, give me some examples. What kind of exercises are we talking about here? Paint a picture for me.
One example Kasser mentions in his paper involves managing a simulated project with limited resources the teams have to make tough decisions about trade-offs, prioritization, and risk management, just like in a real project.
That sounds incredibly challenging, but also incredibly realistic.
Yeah.
I can already imagine the heated debates and frantic calculations as they try to balance those competing demands.
And to make things even more interesting, Kasser throws in some curveballs, unexpected events that force them to adapt and think on their feet. Things like sudden budget cuts, key personnel becoming unavailable, or even a major vendor going bankrupt and being unable to deliver a critical component.
Yikes. Talk about a high-pressure situation, but isn't that the reality of systems engineering? Things rarely go exactly as planned. You have to be able to adapt, improvise, and come up with creative solutions on the fly.
Precisely. And by building these curveballs into the exercises, Kasser is preparing them for those inevitable moments of chaos and uncertainty that they'll encounter in their careers.
It's like they say the best laid plans of mice and men often go awry, but it's how you respond to those unexpected challenges that really defines you as a systems engineer.
And that's the beauty of the balanced classroom. It's not just about imparting knowledge. It's about cultivating a mindset, a way of thinking that will serve them well throughout their careers.
This is also inspiring. I'm already thinking about how I can apply some of these concepts to my own work and learning, but before we get too carried away, let's take a short break. When we come back, we'll wrap up this deep dive into the balanced classroom with some final reflections and key takeaways. Welcome back. So as we're wrapping up our deep dive into the balanced classroom, what stood out to you the most so far?
For me, it's the sheer brilliance of applying systems thinking to the learning process itself.
Right.
Kasser really walks the walk. He's taken those core principles like breaking down complex systems, understanding interconnections, focusing on feedback loops, and he's used them to design a truly holistic and dynamic learning experience.
I totally agree. And it's not just theory. He's actually implemented this approach at the National University of Singapore and has the results to back it up. Students are reporting deeper understanding, increased engagement, and a greater sense of preparedness for real-world challenges.
It's amazing how a shift in perspective, like in this case viewing the classroom as a complex system, can lead to such profound changes in the way we approach education. It makes me wonder what other areas of our lives could benefit from a systems thinking makeover.
Right. Now, I know we've been focusing on systems engineering education, but I think there's some valuable takeaways here for anyone who's involved in learning or teaching, regardless of the field.
Absolutely. Think about the core principles we've discussed: authentic learning, active engagement, collaboration, and a focus on developing those higher-level cognitive skills. These are all transferable to any learning environment, whether it's a corporate training program, a self-directed learning journey, or even just trying to learn a new skill in your free time.
So as we surface from this deep dive, what are some actionable steps our listener could take to incorporate these principles into their own world?
Well, first, I'd encourage them to really think about the concept of authentic learning. How can they create learning experiences that are more relevant to their goals and interests? Could they find ways to simulate real-world scenarios or get hands-on experience?
And what about those engagement strategies? Any tips for staying focused and avoiding those mental snooze fests, whether it's during a lecture meeting or even just trying to read a challenging article?
I think the key is to be an active participant in the learning process. Ask questions, take notes, summarize key points in your own words, and try to connect what you're learning to your existing knowledge and experiences. Don't just passively absorb information. Engage with it.
That's great advice. And if our listener is in a position to influence the learning experiences of others, whether as a teacher, a mentor, or a team leader, what's your biggest takeaway for them?
I'd say don't be afraid to challenge the traditional models, experiment with new approaches. like flipping the classroom, incorporating more group activities, or even just breaking down those long, drawn-out lectures into shorter, more digestible chunks, and most importantly, create an environment where learners feel safe to ask questions, share their ideas, and make mistakes. That's where the real magic happens.
So well said. We've covered a lot of ground in this deep dive, but I think the overarching message is clear. It's time to rethink the way we learn and teach. By embracing the principles of the balanced classroom, we can create more engaging, effective, and ultimately more fulfilling learning experiences for everyone involved.
And who knows, maybe we can even make learning a little bit more fun along the way.
I like the sound of that. Well, that brings us to the end of our deep dive into the balanced classroom. A huge thank you to our expert for sharing their insights, and to you, our listener, for joining us on this journey. We'll include a link to Kasser's full research paper in the show notes if you're interested in exploring these ideas further. Until next time, keep diving deep.
I hope you enjoyed today's deep dive. Why not take a moment and join the discussion in the LinkedIn group Tackling Complex Problems. Take care.